So now I feel kind of bad because I'm actually not going to talk to you about Redux pattern or NgRx like at all. so I'm sorry if you got really excited about that. But I am going to talk to you about state management. I'm going to talk to you about reactive state management. So knowing these kinds of concepts are going to help you understand things like NgRx, but I'm not explicitly going to talk about NgRx. So a little bit about me. My name is Maida, as Juan so eloquently stated already. I work for an identity and access management company called Auth0, so I can also answer questions about authentication and authorization, best practices for those types of things in your JavaScript applications. I'm a GDE and a meetup organizer. Juan already told you that. So state management. When it comes to state management in Angular, we don't really have any shortage of options these days, and for a little while there, actually, it was starting to feel something like this. These state management libraries kept popping up. It's kind of slowed down now, but this was happening sort of a few months ago, and I want to just take a step back for a second to think about why this is. Why are there so many libraries for this now? And it's really this, right? Every application is different. Every team and their needs are different. Every project is different. So what might work for one team is not necessarily going to work for somebody else. And you might use multiple different libraries, multiple different approaches depending on the size of the application that you're building from day to day, or your team structure, things like that. So on that topic, I want to tell you a little bit about an application that I had to build once, or I was part of the process of building it. And this application, I used to work for an agency, and we had a client that was a system of preschools, and they had basically a call center. It was a registration center. Parents or guardians would call up the call center to get their kids registered for preschool. And so the app that I built was the app that the employees of that call center were going to use in order to get the kids registered. Now, when people would call, they would only ever talk to one family at a time. They wouldn't be sort of juggling multiple calls, so you only had to enable them to deal with essentially one piece of state at a time, the current caller. So the state management was relatively simple. There were a lot of things they could do, but it was pretty straightforward. Now, this was an Angular app. I was the primary architect of the application. But the development lifecycle was important in this scenario. So I came in and I built the primary architecture, but after I was done with that, then the next thing that would happen was I was going to pass the development off to another member of my team, and he was a JavaScript developer, mostly presentational JavaScript. He wasn't really an application developer yet. He didn't have any previous experience with frameworks, and he didn't have any experience with Angular or things like Redux pattern or advanced state management libraries. So after he was done with his part on the project too, then it was going to go to the client for maintenance and updates. And the client's team was composed entirely of back-end developers. So in the back end, we don't have things like Redux and stuff like that. So in order for them to maintain this Angular app, they would need to learn a little bit of Angular. But it didn't make sense for me to add a third-party state management library that introduced a whole bunch of new concepts to sort of everybody that was going to follow me in the life cycle of this application's maintenance. So what could I do instead? Well, fortunately, Angular kind of helps us to learn reactive programming also, because it's got this handy-dandy library called RxJS. Now, when it comes to RxJS and managing state reactively, there's no real extra cognitive burden when you are coming into learning Angular and reactive to sort of learn to manage state as just a part of all of that. So if you introduce something like Redux, you've got this whole other set of patterns that you need to learn in addition. But if you're already learning reactive because you're learning Angular, then it's a lot more natural to sort of manage state reactively if you have something pretty simple. Now, one way that we can manage state reactively is by using subjects. Now, subjects are observables, but they have state. So they keep their list of observers. They also implement the observer interface, which lets us do things like run next, error, and complete methods on them. And some subjects actually multicast out of the box. So this means that one observable execution is shared among multiple subscribers. So you can kind of see how these patterns make subject a really good candidate for something like a global store. The thing that happens, though, when you give developers or a team of developers the power of next is it can induce what I like to call sort of a reactive power trip, where they're able to basically just run next all over the application anytime that they want to update the store, and they're super happy, and it turns into a huge mess. All right? So when it comes to managing state reactively with RxJS, you really want to have some kind of strategy in place for your team, because with great power comes great responsibility. We don't want that next all the things. So I'm going to talk to you a little bit about ways to have a strategy or come up with your own, hopefully give you some ideas. One thing that is becoming pretty popular recently is this concept of service with a subject. And the way this works, like on a basic level, is you have some kind of store subject. It's a private behavior subject in maybe a state class, or a state service, excuse me. And so you can instantiate a new behavior subject. You have this subject as private, and there's some unique things about behavior subjects that lend them to being really good candidates for something like global state management. For one thing, they require an initial value. They store the current value. And then they also notify subscribers on subscription. So what this means is when you have a subscriber and you haven't actually pushed anything into your store yet, you have this sort of initial state for your store. If you haven't run the next method on it and emitted any new values, then you're going to get that initial value. If you have emitted any new values, and if there have been several, for example, at any given time that you get a new subscription, they're just going to get the latest emitted value. So you can see how this keeps all of your subscribers in sync with one another. So after you have your private store subject, it's private, you can't really do anything to it in the application otherwise, we're going to create a public store observable, and this is basically going to hide the identity of the source sequence so that we can't just call store$.next from anywhere and everywhere. Now, one important note is you may want to do some kind of transformation on the values that you're going to emit before they actually go into the store. We do that with pipe and then using operators. And the thing is, if you use pipe, this also hides the identity of the source sequence. So if you do this, you actually don't need to use that as observable method. So what we're really doing here is we're trying to prevent leaky abstractions. We want to set up a strategy for how our application should interact with our store. So as a demonstration of this, I built a couple of applications. Now this is the first application. It uses the NASA astronomy picture of the day, so NASA is the United States Space Administration, and what this does actually, and it might be a little tricky to see, but up in that corner there, you can see there's a button with a star in it. And essentially, this application is going to call the NASA API, get the astronomy picture of the day, which I'm going to say APOD now because it's a mouthful. It's going to get the APOD, and then what I can do is I can click on that star button, and it's going to increment this little counter here. And I can also hold the mouse button down on the star button, and it will continually increment until I mouse off or let go of the button. If you're familiar with the way clapping works on the Medium blog, it's pretty much the same thing, just implemented with RxJS. It's basically just an indication of how much I like this picture. So if we look at the code for this, we're going to start out with a state service. And in our state service, we're going to use some of the techniques that I just described. So we have a public APOD store, public observable, and then we have already set up a private APOD subject. And then what we're going to do here, though, is I'm going to use the scan operator. And this gives me access to a couple of interesting things. So first of all, I get access to the accumulated value. So this is essentially the current state. It's the value that's stored in the subject already at the time that I'm running the next method and going to put something new in the subject. So I expect the shape of this accumulated value to be this APOD interface. It's going to have the data from the API, which is like a high-definition URL and title, and then it might have stars, or it might not. It might be just have the data from the API and I haven't added stars, or I may have already added stars and it might have some. Now the other thing that I get here is the new value. This is the one that I've got in the next method as a parameter. I'm sending it in. And this could be the shape of the APOD interface if it's the result of an API call, or it could be this update interface, which is really just an object with stars and then a number of stars. Now, having access to both of these things gives me the ability to create basically my next state. So this is going to be a new object. It's going to be the accumulated value updated with any changes from the new value. And I'm returning a new object here, so this means that it's immutable. So if I want to use OnPush on my components, that's just going to work after I do this. I don't have to do any extra work to make that happen. The shape of this new state is going to be all of the data from the API that we need, as well as maybe stars or maybe not, depending on if we've added them or not. Finally, the last thing here is an initial state, because if there's no initial value passed to the scan function here, like this, then the first value that you emit using next just automatically becomes the first state, and it will skip running through that function. So the next thing that I need here is a way for my application to actually interact with the store, right? So I can set up a public method to send values to my private subject. It's going to expect an object that could be APOD data directly from the API, or it could be the shape of that update object. And I'm just going to run the next method on my private subject to emit that value. And that's actually it for my state service. It's pretty simple. But now I need a way to use the state service, and I'm going to do that in a data service. And the data service in this particular application is the only thing that uses the state service. And the first thing that it's going to do is I'm going to set up an APOD data method that's just going to go and it's going to hit that NASA API. It's going to get the data back from the API, and then I'm going to use the tap operator to run a side effect that takes that data and sets it in the store using the setStore method that I just showed you. Now, the next thing I want to do is set expectations for how my application interacts with the store. Now, this is actually business logic. As you can see, I've actually explicitly called this add stars. It expects a stars object. It's going to run that state setStore method with that stars object, and it makes basically like a rule in the application of this is how you use this. So my app component actually is the last thing. There's not really a whole lot more to this application. You saw it. It's very straightforward and simple. But my app component is going to subscribe to the APOD data, and that's going to fire off that call to the API. And then once it does that, once it's got data from the API, it's going to run a local method called setUpStars. And this method actually looks like this. It's mostly a reactive UI, but it also updates the state. So if we zoom in here, we can see that we have this counter for the number of stars. And then when we have this add star function, what it's going to do is it's going to increment the counter to add stars. And then I'm going to update the state using that add stars method from my data service. Now, the rest of this I'm going to go through a little bit quickly, but it's some fun RxJS stuff. One thing that I'm going to need to do is create a click observable. I'm going to use from event to do that. When somebody clicks that star button, it's going to fire off that event. And then in order to react to values being emitted, I have to subscribe to it, and I'm going to run that add star method, which is going to add a star. Now, the other thing that I want to do, though, is when I'm holding the mouse button down on that star button, I want to continually increment the star counter, right? So there's no like hold from event hold in RxJS, but we can actually make one really easily. So there's a few events that are involved with holding the mouse button down and then letting it go. We have mouse down, which is the first thing that happens, mouse up, and then mouse leave, because if they're still holding the button down, they drag the mouse off the button, I still want it to stop. So then with those streams, I can actually create my own hold stream so that I know when the user's holding that mouse down over the star button. I'm going to take the mouse down event because that's or the stream of mouse downs because that's the first thing that happens in this sequence. Then once I have a value emitted from that, I'm going to use this switch map operator because on every new mouse down, I want a new inner observable to be created and subscribed to, and I want to unsubscribe from the last mouse down event. So that inner observable is actually an interval. And what it's going to do is every 200 milliseconds, it's going to emit a value because I don't want it to just sort of store like forever. As soon as I hold the mouse button down, I want it to just, one at a time emit values. And it's going to continue every 200 milliseconds to emit a value until either the user lets go of the mouse button or they drag the mouse off of the star button. And so basically, when a mouse down event is emitted, every 200 milliseconds, I'm going to emit a value from this stream until the user lets go of the mouse button or moves off the star button. And then I need to subscribe to it, right? So I'm going to run my add star method whenever a value is emitted from my hold stream, and that's going to increment my star counter. And that's actually it. For that example, it was pretty simple. It's fairly straightforward to read. It's a small app with a reactive UI, but this doesn't actually introduce many new concepts to someone who's coming into Angular or RxJS. They can pretty easily see what's going on with the state, and hopefully you can sort of imagine how you could potentially scale this up in other applications. But again, like I said, that was really simple. So what if we wanted to do something that's a little bit more complex? How about something like optimistic updates? So optimistic updates are when we update our local state and our UI optimistically, and then we make a call, like, for example, to our API, and we send data to the API, but we're basically making the assumption that the API call is going to succeed. This can be a nice thing to do if you want your applications to look really fast. For example, if you use Trello, in the web app, you've probably seen this, where it's instant updates in the UI. If something goes wrong, though, you find out like a couple seconds later. So this is something that is useful if you have an API that's very reliable. If you have an API that's prone to failure, optimism isn't probably like on the top of your list. But essentially, if you're doing high-stakes operations, you also would want to avoid this. Changing users' password or financial transactions could sort of end in disaster if you try to do this. But if you have something that is a robust API and it's low stakes, then this can be a neat trick to make your UI look incredibly fast. So I built another application, again, using a different NASA API. And this API goes and grabs all of the asteroids that are close to Earth for a given period of time that you can pass to it. So these are called near-Earth objects. I'm going to call them NEOs because it's easier to say. What this application does is it makes a call to the NASA API, and then it gets the list of near-Earth objects for a certain date range. It puts them into a store, and I can have other views of the segments of the store, bigger, faster ones. There's ones that are really small, like some of these are really small. But if I come back to the home page here, and I open up the inspector, I have added a feature where I can add nicknames to these. So I'm going to open up my console, and then this one's actually flagged by NASA as potentially hazardous. So I'm going to call this one Armageddon, and then I'm going to hit save. Instant UI update, right? That's apparent. Now, a second later, I get the response from the API, and I can see that that nickname has been, change has been made on the server successfully. So if I come over to my other views, I can see that that update has persisted in my store, and it's still there. So let's do another one. This one's really, really, really small. So I'm going to call this one Tiny. I'm going to hit save, and instant UI update, right? But now something went wrong on the API. We were maybe a little overly optimistic. It didn't actually work. So I got this error, and I can do something like pop up a toast in my UI. You can see I rolled back my state, so now it's not saved as Tiny in the store. If I come back to the home page, you can see that that nickname is no longer there because I have reversed it. So how do I do this reactively and in as few lines of code as possible? Well, the first thing that I'm actually going to do is I'm going to create a state class this time because I want to keep my state management logic organized, but I don't actually want to send the message to other developers on my team that this would be an injectable service. I don't really want them to inject it all over the application. So in my class, I'm going to do some things that look pretty similar to the first example. I'm going to create my private NeoStore subject. I'm going to instantiate a behavior subject. And then I'm going to create my public NeoStore observable. I'm just going to use it as observable this time, though, because I don't actually need to do any transformations to values that I'm going to admit. And then the other thing I need to do, though, is create a way to track errors, because I would never push errors into my store. I want them to be separate. I want them to be handled separately. So I'm going to create a private error subject. Again, it's another behavior subject. I'm going to initialize this one with an initial value of null, because we're not starting out with an error right out of the gate. And I'm going to expose this as an observable that the rest of my application can subscribe to. Now, one of the things that I need to be able to do, right, is know what the last state was, because if I do have some kind of error, I need to be able to roll it back. Overly optimistic, have to sort of take back what you said, right? So I'm going to create just a setPrevState method. It's a private method to this state class. I'm going to use a local member called prevState, and basically when this method is run, it's just going to go and get the value from the NeoStore subject. And I'm just going to run this method at appropriate times when I want to actually store this. Now, speaking of errors, I need a way to dismiss errors, because again, my error subject and my store subject don't necessarily communicate directly between each other. So I'm going to create a dismiss error method. It's just going to emit null from my error subject. Now, the next thing I need to do is be able to set my NeoStore, right? So this is going to accept an array of near-Earth objects. This is going to be the list. And the first thing it's going to do is set the previous state. Before I push anything new into the store, I need to make sure that I keep track of what the value was before I make any changes to it. Then I'm just going to emit the neolist that was passed into this method. And then finally, I'm going to dismiss errors just in case we had some kind of interaction with the API previously that went a little awry. Now, the other thing that our application does is it adds nicknames. So that's an update to a specific near-Earth object. So I can set up my update neo method. It's going to accept one near-Earth object, the one that I'm trying to update, right? The first thing I'm going to do here is set the previous state. And then what I'm going to do is create a new state by mapping the previous state. And what this is going to do is it's going to go and find the near-Earth object in the previous state, the one that I'm passing in and updating. It's then going to return a new object in its place with the current object with updates from the object that's being passed in. It's going to return this as a new object so that we get that immutability. We have immutable state, again, so that means that you can use OnPush in your components. I'm going to then emit that new state from my NeoStore subject. And finally, once more, I'm going to clear any errors in case something went wrong. Now, speaking of errors, we have a subject to do something, right? And we also need to roll back the state. So I'm going to add a state error method. It's going to expect a string as a parameter. This could be just, it might be the error message that comes back from the API or something, or it could be your own custom thing. But the first thing it's going to do is it's going to emit that error message from my error subject so that if I'm subscribed to it, I can react to some kind of emission from that subject. Then I'm going to emit my previous state from my NeoStore subject, because part of this whole cycle was optimistically updating something that then went wrong, so I need to roll it back, and that's actually it for that. So the next thing I need, like the other example, is a data service to actually manage the data here. Now, the data service is actually going to extend the state class because I don't want the state class to be injectable on its own. But again, like the previous example, the data service is the only thing in my application that's actually going to use that class. So it makes sense to extend it. I'm going to go through this one a little more visually. I know that was a lot of sort of code slides in a row. So I'm going to fetch the API data from my API by making an HTTP call. And once I get that data, I'm going to use that state class's setNeoStore method to set it in the store, just like the first example. Then the next thing I'm going to do is when we get an update, like I titled this near-Earth object Armageddon, we're going to update the store optimistically using the update neo method from my state class. That's going to update the UI, and it's going to update the local store. And then after I've done that, then I'm going to send that data to the API. like silently in the background. I'm not going to give any indication to the user that's what's happening because they think that I've already made this update. So once I've done that, if everything goes according to plan, then that's it. Nothing else needed. We already updated the state. UI shows the right thing. But if something goes wrong, then I need to be able to handle HTTP errors by using that state error method. So I can then subscribe to my errors observable, and I can do something in the UI in response. For example, you saw this little toast that popped up, and I had an error message outputted to the console. And then I'm also going to restore the previous state. And I can do some sort of fancier things with this. Like, for example, you saw in the application, it sort of keeps track of what the user had entered initially so that it's actually still in the field, but it's not persisted in the store anymore. So if you want your users to have that and then just keep spamming the save button until it works, then you can let them do that. But really, this is an example of something that's a little more complex for state management, right? But it wasn't that much code, and it wasn't drastically different from the first example either, which was very simple. Now, I don't know how many of you have attempted to implement optimistic updates with some of the other state management libraries. It can get pretty gnarly, and this is actually really easy to understand and read. But one of the important things about managing state reactively with RxJS is to know that libraries like NgRx, NgRx Store, use RxJS under the hood. Right? I mean, it's apparent from the name of the library. And if you go in to look at the core code that runs NgRx, for example, this is just the very, very beginning part of the state class from NgRx Store. And just at a quick scan, I actually didn't mean to make that pun, but you can actually see a bunch of things that look really familiar, even from just sort of the 26 minutes that I've been talking about. So really, when it comes to knowing how to manage state reactively using only RxJS, only good things come from doing this. If you do end up using a third-party library like NgRx, knowing how it works under the hood, being able to read the core code and understand it, just helps your understanding, helps you get better with the tools, and just overall, it will make you a more well-rounded Angular developer. The other thing is, this strategy, I showed you a couple of different approaches, but this is really your strategy. You can basically do whatever you want. You can make your own choices. So I showed you something that had business logic in it, right? You can decouple that business logic. It can be completely abstracted away, or don't. Put all your business logic in it if you want. If that's what's best for your team, you can do that. Don't listen to people who tell you, oh, you should never, ever put business logic, in these types of things. You can if it's better for you. You can use more abstraction than what I showed you. You can do getters and setters and sort of build out another layer, another 2 or 3 layers if you want. There's a lot of different strategies and approaches to doing this. There's probably many that are in your heads that I have sort of no knowledge of whatsoever. But the important thing is, knowing the basics helps you make your own choices. So I hope that I've given you some ideas just to start thinking about, to start sort of imagining how you might be able to apply this, how this can help you in your application building and your state management, and your use of third-party tools as well. So the GitHub repo contains both of the sample projects that I have shown here. You can download that, you can look at the code, you can run them. If you have any feedback on them, feel free to open an issue or something. I'd be happy to take a look. The slides are also behind this link. And I really appreciate you giving me 30 minutes of your time today. So thank you very much.